the distinguished participant, esteemed speaker, and respected faculty members. It is pleasure to welcome you all to our day 5 of ATAL sponsored faculty development program on demystifying data for intelligent applications in real world scenario. Over the last 4 days, we have journeyed together through an enriching blend of technical, theoretical foundations, practical demonstrations, and insightful discussions led by experts from academia and industry. Your active engagement, meaningful interactions, and consistent enthusiasm have truly evaluated and elevated the quality of this FDP. As we enter day 5, we move closer to the culmination of this intense program. Today's sessions are designed to deepen our understanding further and help connect the concepts explored so far with real world applications. We are fortunate to have accomplished resource persons who will guide us through advanced topics and that this lead to both timely and relevant to current technical trends. I encourage all participants to continue contributing actively, ask questions, share your perspectives, and collaborate with peers. Your dedication of learning and professional growth ensures that these sessions are not just informative but transformative. Thank you for being an integral part of this FDP. Wishing everyone an insightful, engaging, and productive day 5. Today's first speaker is Mrs. Ahana Mitra. Ahana Mitra has over 15 years of experience in the data domain and has held multiple head of data positions. She has worked several Fortunate 500 companies, helping them mine, analyze, and derive insights from data across varying volumes, varieties, and velocities. Currently, Ahana is the founder of a quantitative trading firm in London, UK, where she leverages machine learning algorithms to analyze market movement. Welcome, Ahana.
Thank you, Kajiri. Am I audible?
Yes, you are.
Wonderful. Thank you so much, Kajiri, for this very wonderful introduction. And I'm so excited to be part of this session. A very, very warm welcome to everyone who has joined the session today. So I will start sharing my screen. I wanted to show you my face just to make sure that I'm not an AI robot, I'm a real person. So now that you've all seen me, I will switch off my camera and we will just dive into our presentation. Cool. I assume everyone can see this?
Yes.
Cool, perfect. So today's topic is demystifying data for intelligent applications in real world scenarios. So what I've done is the way I've structured today's presentation is basically 3 parts, which is demystifying the data, which is the absolute gold that we are mining and gathering within the business and the corporate world, and how we can use that for intelligent applications. That will be the second part of our presentation. And then examples, my personal experience of using this data in the real world, building machine learning algorithms, etc., basically to benefit the business in terms of improving sales, engagement, revenue, and so on. At the end of the day, in the real world, in the corporate world, businesses are only interested in how to maximize revenue, sales, engagement, right? Cool. So I'll just try to close this. Yes, a quick introduction of myself. Kajari has already given an introduction, but I have had multiple, experiences working with so many different companies in different parts of the world. I worked in 4 different continents, multiple countries, and I have worked with organizations with varying maturity of data and analytics. I worked in startups, which are generally very agile. And I've also worked with big dinosaur corporates who are still trying to figure out, how to get my data clean to be able to use it for analytics and so on. So I hopefully the examples that I share with you today will be beneficial because they come absolutely and entirely from my hands-on experience in the corporate world. As Kadri mentioned, I'm still involved with data. I'm very hands-on. I have a small startup where I do all the hands-on coding, etc., and I love doing that. I've also left my LinkedIn account over here. If after this session anyone is interested in connecting or has any follow-up questions that we are not able to attend to today, I'll be more than happy to answer it once you connect with me. Cool. Again, quickly, today's time distribution. I believe we have already spent 7 minutes, but we will try to be on time and and try to end the session on time. So how I have structured this presentation, like I said, predominantly three parts: data, intelligent applications, and real world examples. It is very important for me that we spend a good significant amount of time on data, which is basically, if you don't have good data, there is no way you are able to use any sorts of analytics. Forget about even AI, right? So I will help you understand the nuances of data in the corporate or the real world. And then once we have this data, how do we know what intelligent applications to build? uh, I have this data, so who will decide, like how to get outcomes, good outcomes from it? How do I use this data to drive sales? How do I use this data to drive engagement? What do I do with it? Who do I give it to? So that's an important aspect of data as well. And finally, the real world example that I will focus on today is personalization engine. You all would have had experience of it. I'll deep dive further into it, but this is at a high level. It is basically how to build a personalized experience for every individual customer, right? You have various apps that you use. It could be a OTT, it could be, Amazon and Spotify and so on. How do these organizations give you a personalized experience? And finally, I have also set some time out to show you how to build this type of personalization engine. Unfortunately, I can't share real data because we signed non-disclosure agreements with companies we work for. However, I will show you how to create mock data, how to then build these neural network or AI or machine learning algorithms. I've used Python for it, and we'll go through that. That'll be quite exciting. And after the session, Kajari will be, for those interested, she will pass on this code to you. And I've left some time in the end for Q&A. I would love to get your questions, but for any reason we are not able to reach to the Q&A, again, reach out to me over LinkedIn, reach out to the, Kajari and her team, send me a question. I'll be very happy to answer it. Okay, so now we will deep dive into the data. I will assume that, Kajari, we are looking at the chat as well. If there's any pressing question, if you can't hear me, or if you have any issues, I'm going fast, etc. Kajari, please do stop me and I will make changes based on your feedback because I can't see the chat, etc.
Definitely, definitely.
Thank you. Thank you so much. Okay. Part one, data, right? So in an organization, it's we have multiple sources of data, right? Data that comes from, let's say, your transactions. Data that comes from that tells us more about you. It could be, your gender, your date of birth, your where you live, which state you live, which city you live, what is your postcode, and so on, right? If you are, say, a company like Amazon, what was your app usage like, right? What time of the day you joined the app? What were you looking through? What were you browsing through? Uh, Again, in the same example, if you are a manufacturer or Amazon, information about your warehouse, your supply chain, people who are helping you deliver your products and so on, right? And there's survey data, and there is so much data that these organizations are actually capturing, and that is available. So, from an organization point of view, the absolute basic necessity is that the organizations bring this together, that all the different sources of data together. And mind you, these data are not clean. They can be very, very, very unclean and with quality issues. And we'll get to that very soon. But the important thing is they have to be brought together, they have to be categorized. And the most important thing, these have to be made available uniformly for wider consumption across the organization. And what do I mean by that? If I am a marketing manager in an organization, I need to have access to all the data and information that is relevant for me. If I'm the sales manager of an organization, all the relevant information for me I should have access to it, right? So that's basically the role of a data team in the organization to take care of these three things. So data moves fast with an organization. Again, you may or may not be aware. If it's a pretty large organization, there are hundreds and millions of rows of data that goes through a system within an organization, right? And sometimes hundreds of millions per minute or per hour. So there's huge, absolutely huge amounts of data that organizations are collecting, and that's happening with because we have better infrastructure, we have better ways to, we use cloud facilities and so on, they're cheaper, etc. So capturing data has become so much easier. But what are the different kinds of data in an organization, right? In terms of, I've given you examples of data, but broadly, because there are different kinds of organization. Say, for instance, company like Pepsi. I mentioned Pepsi because when I was in Australia, I worked for a beer manufacturing company called Asahi, and they were also distributors of Pepsi in Australia and New Zealand. Now it's a manufacturing company, right? So a company which is a manufacturing company will not have information about its customers, because what is it doing? It's manufacturing Pepsi and it's selling it off to, let's say, a supermarket. Say I'm manufacturing Pepsi and I'm selling it to Spencer's and Amazon. I don't know who Spencer's is sending to. So from a data point of view, I just have information about my manufacturing, my supply chain, and how much I'm say selling to my different, supermarkets and so on, or maybe the shop at in your apartment and so on, right? Those mom and pop stores, as we call them. So basically data is of three types, right? First, second, and third. So in this scenario, first party data is the data that I generate, right? So for Pepsi, as an example, first party data is all the data I just said, how much I'm manufacturing and so on and so forth. But I'm missing the customer side of data. So now if I tell Spencer's, hey, I want to join hands with you, I will share some data with you, or I will give you some discounts. Can you give me the point of sales data of the customers, just so that I understand what is, how is the customer, what kind of, or how many transactions are customers doing, or what does that data look like? So that becomes second party data, where my partners are giving back my data back to me, but at a different granularity. So at Spencer's, say for instance, you are purchasing Pepsi. So I give that data back to Pepsi so that they can use for different kind of strategies and so on, right? So first party data, I'm generating it myself. Second party, I'm getting it from my partners. Third party data is mostly surveys, and they're also called scan data. Nielsen, for instance, is a data company that surveys different households just to understand, what is their grocery purchases like and so on. So you also get like competitive data from third party data. Obviously, Coke is not going to sit there and give their data to Pepsi, right? How does Pepsi understand how the competition is doing? It's through third party data, it's through surveys and so on. So I hope you're able to appreciate that not only are the different like kinds of data, they are also like this first, second, third. So you can understand that data is not as easy as it sounds. There's a huge complexity going around it. And all of these data sources that are flowing through the organization come in different volumes, variety, and velocity. Some of these data are real time. Some of these data comes in batches. Some of these data, survey data, for instance, could be 2,000 rows of data. Transactional data could be 50 million rows of data. And we've already spoken about the different varieties. And mind you, data is not just numbers. Give These days, data can be, say, a voice note. It could be an image. So data is coming in so many different forms in today's day and world. One more thing that is really important from a corporate point of view are data issues. Because we are getting data, right, from multiple different sources, right? And there is first, second, third party. There's your social media data, and there's your transactional data, and there's app usage data, and something is real time, and something is at a day level, and so on. It is very likely there'll be issues in the data, right? Some data can be at a customer level, some data can be at a date cross transactional level, and so on and so forth. So it's very complex. So it's very important. It's a critical step in any data analysis to ensure the quality of data, right? At the end of the day, if the data that you're using to build your analysis or your models, AI models, ML models, it will be garbage. If there is garbage data going in, the output that you will get is garbage data, right? And we have seen this so many times. I'm not sure if you're aware of some of these examples. Even I wouldn't name brands or people, etc., but I have seen so many examples of where people are just mentioning or throwing numbers which make no sense because the data that they use was, absolute, uh, let's say, garbage, right? But it'll be important for you to just appreciate some of the different kinds of data issues which are commonly seen when you use the data. Uh, One is duplicate data. A lot of times, what happens is that the same data is duplicated, right? If you see over here, customer ID 2256, pet food, 1st March 2023, the same one is repeated again. Now imagine you had this duplicated data and you have a sales report that is going to your CEO every week. Suddenly the CEO is like, oh, wow, my sales has doubled versus last week. What's going on? Amazing. And then you go back and say, oops, actually, we had a data quality issue. It's just that all our rows were duplicated. And it's quite common, right? So we have to have measures in place that are able to identify these issues. And before it goes to someone senior or before it goes into making some decision, we have to be able to rectify these. Another example is incomplete data. What is incomplete data? Just something is missing, right? So there's missing data. So here in this example, let's say there's a category name that is missing, right? So again, there could be ways of mitigating this. First, finding out why maybe there's a new category that was introduced, or maybe that category doesn't exist anymore because of, say, some government rules, etc. Say, for instance, in a new state, you're selling alcohol or cigarettes, and the state says that the government rules that you can't sell them anymore. So obviously, you can't have that data. Or it just could be like, sometimes it's also very difficult to explain why something is missing, and it could be just no reason. Someone messed up in the data engineering team, right? The third type of data issue is inconsistent data. So if you look at the transaction date under inconsistent data, one is in DDMMYY, the other one is YYMMDD, right? Because you're getting data from multiple different sources, it is possible that there is an issue with the format of the data and so on, right? So that's a very common data issue. Invalid data, say the first row, you can see it says 1900. I don't think even the internet existed in 1900. So obviously the data is an issue. But if you see the last one, inaccurate data, and you will appreciate why it's important to clean the data. Say you use this transaction date of the invalid data to find a metric, to build a metric for the business, which is, say, days since last purchase. So how many days has passed or interpurchase interval, and the value you're going to get is almost 45,000 days. I don't know if anyone lives that long also. I'm pretty sure they don't. So these are the issues that can arrive, right? So it is therefore very important when you're dealing with so many complex and so many variety and such volumes of data. It's important that the quality of your data is absolutely pristine, because this is the most important step before you run any analysis. And like I said, it's very commonly used, GIGO, garbage in, garbage out. And this is the only truth about data. If you use poor data, without a doubt, you will get outcomes that are absolutely unusable, absolutely of no use to the business. Okay. Um, Let me see how we are going on time. We have 150. Okay, cool. I think we are going pretty well. Um, Although, please do keep your questions, etc., written at the end of the presentation or between maybe when we move to the coding, etc. I'll try and pick a few questions just to break it down. Um, so now, yes, again, so the topic of our presentation is demystifying data for intelligent applications in real world scenarios. And now we are on to the next step, which is intelligent applications, right? But quickly summarizing data, what do we understand? There are multiple sources of data. They come in different volumes and variety and velocity. And it's really important that we clean it, because if we don't clean it, we will not be able to intelligently apply that data, right? I think very simple, clear. So the next part is, so how, now that I have all this data, okay, I am part of this big organization and I have been able to get clean data. So now what do I do with it? And how do I know what I want from it? So to make the lives easier for an organization, this is a very commonly used framework, right? I will explain the different coordinates of this chart, etc., just so that it's clear. I know it can be a bit overwhelming, a lot of text and stuff written here. So I'll start with the x-axis, right? The x-axis is the analytical maturity of an organization, which essentially means how matured are they in terms of using a data. So based on my experience, typically say a tech-based, say startup-ish sort of a company, they are they're actually very analytically mature because they have more or less clean data, or they have access to data, right? And they are able to very quickly, uh, you know, go up on this maturity curve, as opposed to, let's say, an organization which has been around for a very long time, which has been around for, see, for instance, I work for Asahi Beverages, and it's over 100-year-old organization. So it existed and thrived before even, we had these whole concepts of data analytics and so on. So for an organization like that, uh, it can be a slightly different approach and a different trajectory, right, of maturity compared to, let's say, a fintech company that I had joined, which was relatively new, but they were very agile. It was a smaller organization and so on, right? So that is analytical maturity. Like, where are they and how comfortable they are in terms of their data, how clean their data is, data available at all or not, right? The y-axis here, it's competitive advantage. And what we are trying to show is that the more mature a business is, the better competitive advantage it'll have. And why do you think that is? Because the more we are able to utilize our data, the essentially meaning the more we are able to be engaged with our customers. The more we are engaged with our customers, the more it's likely that they will buy more stuff from us. And the more they buy stuff from us, it means more revenue for us. So that is typically, well-known sort of a rule that, and imagine if we are using data better, compared to our competition, then even that's even better for us, right? So not only are we doing great in terms of our customers, they love us, but we're also doing better than the competition. So in today's day and age, it has become absolutely inevitable that we have to use data, and the sooner and the quicker we mature, the better for the organization, right? So we start with here, if you look at the bubbles, you start with the raw data, and then you move on to the clean data, which we've already covered in the previous section. And then the first thing we typically do when we have data, an organization, what does it want to know? It wants to know, what is the health of my organization? Why do you build a business? You build business to make profits. You build business to drive revenue, right? So standard reports are very simple, static reports. Even from an academic point of view, like it could be how many students enrolled last year versus this year. Maybe it increased by 10% or decreased by 10%, and whatever would be the reason. So these are very simple reports, and they are used across the board, across industries, right? That's the absolute basic requirement, like absolute basic utilization of data. And then comes the four different types of analytics. Descriptive, again, standard reports and descriptive is more or less the same. It's just analyzing the data, and usually performed manually or can be automated, honestly, but it's very similar. How did sales perform? How was my revenue this week versus last week? What is the moving average of, and so on and so forth. Very basic reporting. So it's what is it basically, what it's saying, that what happened? That's what it's trying to do. So that is called descriptive analysis, right? What happened? But when you know what happened, when you know that sales went up this Diwali by 50% versus last Diwali, the obvious question is why, right? Great, it went up, or maybe it went down, but either way, you want to know why. Why do you want to know why? Because you want to be able to replicate that if your sales went up this Diwali. So what happened? Why did it go up? So that is diagnostic analysis. So you try to diagnose what drove my sales to go up. Do I have more customers this year? Are customers buying more this year? Were there any promotions going that led to it? So on and so forth, right? So, or did we, go into new markets that we didn't have last year, and so on. So that's diagnostic analysis. So what happened, and then why happened? The next part of this curve is where we start. If an organization has a lot of data, they have the right capabilities and skill, then when they know why it happened, they want to be able to predict what will happen next year. I know this year, this Diwali, my sales increased by 50%. And I know why it happened, right? I know it was the promotions, I know it was the new markets, and also uh, maybe the new product that we launched was a hit. So, what will happen next year, right? So, can we build a predictive model to tell me, given all of these inputs remain the same, or maybe there could be something new next year as well, what will it be 50%, or will it be 70%, or is my sales likely to go down next year? So that capability is basically predictive capability, able to foresee the future, right? And the final one in this framework is called prescriptive analytics. And prescriptive analytics is basically using data and complex algorithm, AI, ML, and all of that, to help, and letting the algorithm tell us what is the best course of action, right? You know that sales went up, are going to go up 60% next year also. Can the algorithm, given the data, tell me who to promote these, who to send promotions to so that I reach that 60%, or which new markets I should reach out to so that I reach that 60%? And you let the algorithm, given all the historical data that you have, suggest you your next best action, and prescribe you or recommend you your next best action to be able to reach your business goals, right? So again, this framework is very useful, and it's used across the board, uh, across different maturities of data and organizations. Hopefully this is clear.
Kahuna, there is one question
And
in a chat. Mr.
yes.
Ajitesh Moy Ghosh,
Mhm,
he asked,
mhm.
how does cueness of graph can predict data and help us in data pre-processing?
I'm sorry, how does
How
skewness
does
of graph?
your this graph, I guess,
Okay.
can predict data and help us in data pre-processing?
So data skewness, I think it will come as part of data issues. Um, Data skewness occurs, I'll tell you. So this chart that I'm showing, it's a framework. So there is no underlying. So what you're talking about is clean data. So to be able to reach from raw data to clean data, you have to ensure, like I mentioned, all the different skewness and etc. Sorry, all the different issues. So skewness is also an issue. So I'll give you an example of skewness. Say, for instance, you had a promotion, right? And you reached out to, say, only women in that promotion. And suddenly, obviously, your sales went up in 1 week. Okay. And next week, your sales normalized, right? So when your sales normalize, if you look at the data by gender, you will think that, oh, women stopped buying things from, my shop. But that is actually not accurate. Your data is skewed because you had a promotion running and that was specifically targeted to women, right? So it's not accurate when you say that, the next week the data, women stopped buying or they're buying less and so on. So there are multiple ways that you can improve the skewness of data. I mean, there are different ways. Again, there could be different ways of looking at. Typically, when we actually clean the data, we use histograms, right? Histograms is when your data kind of follows any data in general follows a normal curve, right? So we look at those, and if we see some abnormalities and so on, typically data engineering teams, they look at it, why that happened. It could be due to duplicate data and so on and so forth. So this framework that I'm talking about here, right, it's just a framework. This graph has not been created with data. So if there is skewness in your data, obviously, yeah, if you try to predict your sales and so on and so forth, it will get impacted. But we'll get to that later when we get to actual granular data. Hopefully this is clear. Okay, cool. So another thing I think it's really important for you to understand from, again, an organizational point of view. And again, I want you to appreciate that all of this that I'm discussing, we still haven't reached the data part. It's important to understand what's happening under the hood in an organization before you reach to AI. Because to be very honest, you can go to ChatGPT and just write the name of an algorithm and ask it to give you that code. And honestly, you don't really need, a PowerPoint presentation to explain that, right? You can, that kind of information is available, but you have to understand what's happening under the hood in terms of the whole entire spectrum, all the way from pulling the data to then utilizing it, right? So that you're able to appreciate that what is that journey that data is following, right? It's not just the algorithm, but the whole journey of the data that it's following. How do you make decisions and so on and so forth? So that's really important. How do we join the dots from the raw data all the way to predictive and prescriptive data? Anyway, the last part about intelligent application, uh, this is basically how an organization is structured, right? From a data point of view, like a data team in an organization will look something like that. So we spoke about cleaning the data and so on. So that is taken care of by the data engineering team. It's typically called a data engineering team. They are the one that bring all these different data sources together from all these different places. They unify it, they clean it. If the data is skewed, they will figure out a way to identify it and clean it. Why? Because when we predict in the future our sales, we can't use that skewed data, right? And then again, build all the different kind of analytics and so on. So data engineering team just make sure that data is available in tables and so on in an organization. And then the way it's consumed is twofold, right? And this depends again on the maturity of the organization. Data self-services, you would have heard of different dashboards and so on that different organizations use. So enable, this is basically the descriptive analytics and maybe to some extent the diagnostic analysis. Data has to be available to everyone in the organization to help them make the right decision to drive revenue, sales, engagement, and so on, right? a company will be doing itself a huge disservice if someone within the organization could have made a right action or decision but didn't have the data access to do that. So democratization of data is what we call it, right? So typically within an organization, people have access to the data that is relevant to them. The other use case for this data, which we'll focus on today, is data science, which is solving the high value business problems, right? Using AI, ML, again, depending on the maturity of the organization and the skills and capabilities of the team, they're going to do that. So it's really important. I think one thing is worth mentioning, not all organizations have the skills and capability to build AI, ML algorithms and have these sort of things. And the reason for that is these skills are quite expensive. Hiring a data scientist is quite expensive. Hiring data engineers is quite expensive. Very small startups, they can't afford these sort of skills. So it's really important to appreciate that all of these actually come together, and it requires a skill to be able to have this sort of capabilities. Cool. So quickly wrapping up the last two sections, we spoke about data, why it's important, the kinds of issues with the data, and in the second section, we understood now if we have data, what sort of analytics is most suitable for us, right? And also what kind of capabilities an organization needs to be able to fulfill those uh, needs of the organization so that they can utilize data to do whatever it is that they want to do. I will again quickly do a time check and see how we are going. So we are fine. I think we are 37 minutes out. So all good. Again, before I move on, any more questions that you want to just quickly data and intelligent application before we move on to real world scenario? Seems like this is a good time where we can just, I can quickly take a few questions.
Yes, participant, you can unmute yourself and ask the question directly.
No, no questions. Cool. Okay, no worries. All good. I am just hoping that you all are listening. Uh, I might just have a pop quiz on the chat very soon. So please be attentive. The next part is important, as for the last two parts. But I'm really hoping that you have not just muted yourself and closed your cameras and nobody's listening. Yeah? Okay, cool. So we'll move on to the real world scenarios. So before we move on to the real world scenario, I want to give you or show you an example of something that could potentially is familiar for you, right? Do you find any of these examples familiar? I will run you through both of them. Okay, on the left-hand side, let's assume this is a shop which you go to. It's a standalone mom and pop store, maybe a shop in your building, right? Apartment. So the shopkeeper here is saying, here's an additional 5% discount for being my loyal customer. And the customer Geetika is saying, oh, thank you. I love shopping here, right? So I hope you're able to appreciate that. Not only does the shopkeeper know Geetika, he has also kept a tab of how often Geetika is coming to the store, and he is able to, appreciate that, and then goes ahead and personalizes the whole experience for her and says that, hey, how about 5% discount because you've been so loyal to me. Geetika has so many different options. She can also go to Spencer's or she can go to the other shop next door and so on. But she has chosen to come to this shopkeeper, and makes sense for her to keep shopping there because she gets these discounts, right? On the right hand side is another example where our customer Anju, so she says, I've run out of cooking oil and I need to replenish it. Can you get me a bottle, please? So she asks the shopkeeper, hey, I want a bottle of oil. Like maybe she's in the middle of cooking and she realized, oops, I've run out of oil. So the shopkeeper says, here, try this new brand. It's healthier, and your friend Geetika also purchased it last week. So here, what is the shopkeeper doing? So he knows that Geetika is most likely open to trying new brands. So he sells the brand by saying that it's healthier. And something else that he does is that he says your friend also bought it. So he knows that if Geetika buys something, Anju will most likely buy it because they are good friends, right? So these are the kind of personalized experiences we are used to having when we go to, like a face to face sort of a shop, right? When we go to a shop face to face in person, when we go, I'm not talking about your Spencers and so on. Those guys don't have this sort of personalization, unfortunately. But if you go to your Kirana store or, like the store next door, you will have this experience. Now imagine that there are tens of millions of customers coming to this shop, right? I don't think either of these shopkeepers will be able to give that personalized experience, right? And that is what's happening in the online world, in the world of Big Basket and Amazon Fresh and all the different, like apps, etc., that you use to buy different sorts of things. Tens of millions of customers are coming to your app. Then how do you give this sort of an experience to each and every customer who looks different, has different buying needs, has different history, lives in different places, and so on and so forth? So that is what we do with a personalization engine. Uh, a lot of organizations build personalization engine just for that exact, to give you this exact experience in the online digital world. And why do we do that? Businesses are interested in giving you a personalized experience predominantly for these three reasons. There could be more, but predominantly, I would say that based on my experience, these are the driving forces for why a business will build a personalization engine or a recommendation engine, right? Why would it like to personalize your experience? First, it wants to increase your engagement. So, say, for instance, you are using an app to buy your groceries, right? If you like what you're seeing, you will spend more time on that app. The more time you spend on that app, the less time you'll spend on other apps. The more time you spend on this app, the higher likelihood that you will buy something from this app, right? So it's important that if I am able to give you a personalized experience in the app that you're using, you'll spend more time or you'll be a highly engaged customer for me. The second thing why personalization is important is it boosts CLV or customer lifetime value. Again, I don't know if you're aware of this term, but I will explain. Customer lifetime value, it's a very commonly used word in the industry, especially customer facing businesses. We call them B2C, business to customer businesses, such as your Amazon, Big Basket, Spotify, and so on. What is a customer lifetime value? So basically, it's high, medium, low. Just to explain it very simply, a high CLV customer or high customer lifetime value customer is someone who has who has high recency. Basically, they have recently purchased from you, they have high frequency of purchase, and they spend a lot of money. So not only are they spending a lot, they're spending frequently, and they have also spent most recently, right? And a low customer lifetime value is someone doesn't spend that much, and even if they spend, it's not a lot, and maybe the last time they spent money with you was maybe 1 or 2 months back, and so on. So obviously it's important that you are able to migrate your low customer lifetime value to high customer lifetime value, right? Because that means better business for you, that means win-win for everyone, right? And how do you do that? Personalization could be one of the levers that you can use to increase your lifetime value of your customers, identify customer needs, and targeting them with tailored solutions can significantly enhance long-term value, right? And the third thing, why personalization is important, it's to reduce customer dormancy. So it's very common, for instance, like say a Big Basket, you didn't like it's just showing random things. It's not say things that you want to see. For instance, say they were not doing personalization in that scenario. Obviously, you prefer maybe another app who took better care of you and so on, and you would leave that app and join a new app. Or maybe you had a poor experience with one of these companies companies and you move on to the next one. So how do you proactively engage customer segments that show a sign of lapse and so on, and how can you reactivate that? So again, personalization is a lever that businesses utilize for this purpose. Okay, so now we are slowly getting into the actual, types of personalization, and getting into the details of personalization, right? Personalization is not one size fit all. It is not. It's not just, oh, personalization, I just show you what you. There are different kinds of personalization, and it's important to be very clear about. Again, this is kind of a framework, but it's important from an organization that you are clear about what kind of personalization is suitable for you and what kind of personalization, like you again have the capability and skills to deliver. And what are these kinds of personalization, right? So the first one is called repurchase, right? Repurchase is very simple. It's basically, you've bought something and you buy that on a regular basis. And when it's time for you to buy it again, I will just remind you that, hey, it's time for you to buy it. So I put a screenshot. I have a dog. His name is Jamun. We buy a lot of pet stuff from Amazon for Jamun. So this screenshot was taken just, I think, a few days back, because it was almost time for us to, replenish his pet food and some of his medication. So what is Amazon telling me? It's saying that, hey, you bought these things. It's been a few days. Would you like to buy it again? It's good for me because I suddenly just, like, it's like a reinforcing me to think, oh yes, that's right. I'm out of Jamun's food. So yes, I need to buy. I'll just quickly click on it and buy it. Right. So repurchases, it's identified that I buy these things on a regular basis, and it's just showcasing, personalizing my experience just to show, hey, buy again, right? The second type of personalization is called substitutes. So, say for instance, I bought some athletic wear. Again, I'll name a few brands because it'll make it easier for us to understand. Let's say I bought it from Nike, right? I bought some athletic wear from Nike, and the app then sends me an email saying that, hey, you know what, Adidas also has something similar, and that is actually it's more popular and so on, so would you be interested in buying that, right? If you think about it, this experience is quite similar to our real experience, where the shopkeeper was trying to sell this new oil to Anju, right, saying that, hey, try out this new oil, it's healthier, you might be interested in it, maybe you need it now, or so on. So very similar to that. If you see, again, this is a real example. The Iconic is an Australian fashion brand, very similar to Mintra in India. So I had bought an athletic wear, so after a few weeks it actually sends me Adidas, and it clearly I can see it's almost 50% off. And it makes a lot of sense to, if I am going to the gym on a regular basis, this it makes sense for me to buy that product, right? The third one is discovery. It's the third type of personalization, right? What is discovery, right? I have given an example from Spotify. I assume Spotify is also popular in India. I'm just thinking if there's any other brand, maybe Ghana.com or something like that. I assume they're quite similar. So what it does is, for instance, say I listen to Arijit Singh and A.R. Rahman, right? I listen to these two singers on a regular basis. And what Spotify will do is that, or what this app is going to do, it's going to look at people similar to me, who look like me, could be from a similar location also, and then say, hey, within the algorithm, people who listen to Arijit Singh and A.R. Rahman also listen to Ed Sheeran, right? And it'll recommend me songs from Ed Sheeran, right? So that is discovery. Ed Sheeran is something I have not listened to before. But the algorithm figures out that people who look like me and have behave like me, right, tend to listen to and like Ed Sheeran, and therefore it'll recommend me that. Right, so that is discovery, helping me discover new brands and new experiences based on lookalike people, right? So, repurchase, buying the same product again and again, just nudging me on that substitute. It's a substitute. It's a product that is, say, the most popular within the category that I've bought before, and discovery is helping me discover new brands and products. Is it clear? Any questions on these three types of personalization? No? Okay. I assume it's clear then, right?
Yes, it is. I think it's clear.
Okay, perfect. So now everything looks very easy in words, etc., and so on. However, while repurchase is from an algorithm point of view is an easy, I'd say relatively easy way to solve, but we do use AI and ML coding for discovery, and we'll come to that soon. So for today's presentation, I focused on repurchase and discovery. So how do we do that, oops, in the real world scenario, right? What does the data look like? How do we calculate repurchases, as well as how do we calculate discovery? Just before we move into, I'm just looking at time, we have 40 minutes, so which is good. Before we move into the hows and the data, just a quick recap. I assume that, Kajari, is it okay for me to assume that the group here has gone through this, like so
Yes,
difference
yes,
between
yes,
super?
yes, yes,
Okay,
yes, yes.
perfect, excellent. Very, very good. So basically, I will just do like a 1 minute overview. Unsupervised, supervised, and reinforcement learning, different types of machine learning languages. Unsupervised is where we throw all the data into the algorithm and say, hey, algorithm, you go figure it out, right? You tell me, you give me the insights of what I'm looking at. Supervised is, okay, this is my really nice data set, and my sales was this and my marketing spend was this, and every time I spent so much money on my marketing, my sales actually went up. This was history. What will the future look like if my marketing spends go up or down, and so on? So supervise, label data, learns from historical data, and trains based on historical data, and then you can use it for predictions. Reinforcement, again, a quick one. It learns on the go. It gets penalized if there are problems, and it gets awarded if things are going fine, like self-driving cars and so on. Right? For our analysis, for discovery, we are going to use unsupervised learning. We will see how we can use unsupervised machine learning for it to give us insights on what is that new category or new brand that my customers should discover. Okay, now repurchase behavior diagnostic analysis deep dive. So this is again, say one customer, they purchase shoes, beverages, and pet food. So customer X previously purchased branded shoes along with non-alcoholic beverages and pet food. They can be retargeted with a nudge to purchase these items on their based on the inter-purchase interval. So inter-purchase interval is nothing but on an average, how often do you purchase? So basically, when did you purchase last? And if you're purchasing today, what's the difference in number of days, right, that you purchased something? So on an average, like an inter-purchase interval could be, like maybe every 5 days you purchase, every 10 days you purchase, and so on and so forth. So on the right-hand side, I'll give it just a slightly more explained, is you bought your pet, I bought food for my beautiful dog here. Uh, and then after 20 days, I bought pet food for him again. And then after 20 days, I bought pet food for him again. And then after 30 days, maybe I was traveling, or maybe I had bought a better, bigger pack or something. And then I bought pet food again. So it is very clear what it's very predictable, kind of, how I purchase food for Jamun. which is on an average every 20 to 25 days. So now every time I go to this app, if the app actually nudges me that, hey, buy this food again, it's almost time, or, in the next 5 days, we are running some, let's say, promotions and so on. So buy this pet food. So if I have that personalized experience in this app versus some other app or so on and so forth, obviously I will be, let's say, even if that comes with a promotion, I will most likely be inclined to make my purchase. So how do we do this? Okay, and again, I believe that this has already been covered. Like there are predominantly two coding languages for AI ML. It's R, the letter of the alphabet R, and Python. There are other languages also, but predominantly these are used. R used to be used earlier in the past. I'm very fluent in R, and I can, let's say I don't need ChatGPT to do a code in R. The code on the left-hand side is written in R. But having said that, all of this can be replicated in Python very, very easily. But this is, I just copy pasted the real code that I had written in the past, just to give you some idea of what it looks like to code in R. So what I've done here is, and the data, sorry, on the right hand side, like I said, I could not legally share actual data. So I just created some mock data. The structure of data more or less looks the same for any, let's say, groceries company. I don't think it looks too different. It could be more granular, but at a subcategory level, it'll look kind of like this, right? So customer one, if you look at customer ID one, you have all these different subcategories. So the transaction date is sorted, right? And then to find the interpurchase interval, what I've done is we've taken a lag of the transaction date. So basically from this 132033 onwards, from the second row here, we've just brought it here. And then we've just done a minus in terms of days, right? That is the interpurchase interval at a customer level, right? On an average, how often does a customer buy? So if you take an average of this is average API of 20 days. So let's say this is my transactional history. On an average, Ahana buys every 20 days from my company or from my app, which I think is pretty great. It's a good, if I buy, which essentially means I purchase 3 times in 2 months, which in my mind is pretty good, right? Like for an I mean, I would say I'm, if not a high CLV customer, I'm at least a medium CLV customer who's coming back on a regular basis, right? So that's an insight that you can draw at a customer level IPI. But if you look at the bottom, I think what becomes more interesting and informational from a personalization point of view is when you have the same data at a subcategory level, right? You have pet food, shoes, and beverages. So you do the exact same exercise, right? But at a subcategory level. So on an average, Ahana buys pet food every month, like 33 days, like every month. She buys beverages every, say, 2 or 3-ish months. If you look at shoes, it's a bit odd, right? Like the interpurchase interval is like 109 days, which like, and next is 5. So again, when you have real world data, you have to make that call, right? Like, is 57, does it make sense, like, to 57 a good IPI, given I just have 2 data points and it's shoes and one is 109 and the other one is 5? Like, it almost looks like a fluke. It doesn't seem like this is a pattern and so on. So a lot of times you'll have to code in these business rules. How many data points do you want to use to be able to calculate IPI? Are you going to do a median interpurchase interval? Are you going to do an average interpurchase interval, and so on? So those become really important, right? So I'll just quickly run you through. I mean, these are very basic steps, but again, quickly run you through these. So how do we accurately identify which customers regularly repurchase product and what those products are? It's very simple. Identify your regular buyers based on high frequency, recency, transactional volume. Obviously, customers where you don't have a lot of data or who are new to your business, so they have only one purchase, right? I don't think you'll be able to. You can try as an experiment, which is fair enough to do, but interpurchase intervals can't be calculated for fresh customers, right? And then you will have to therefore filter out customers who have at least more than two historical transactions. And you can do multiple experiments to see, right? How does this work for customers who have more than 10 transactions versus more than 100 versus new customers? And you can create different cohorts and do all of this analysis and so on, right? And then you calculate the interpurchase interval, basic number of days between consecutive transactions, and then derive an IPI benchmark, which is what we've done here, 33 for pet food, and for beverages 81. Shoes, well, I'll leave it to you to decide whether you want to. No harm in showing. Again, you can run an experiment. What if we show a repurchase ad, a repurchase nudge or personalized experience to this customer? Do they buy something? Do they engage? They don't. So we run a lot of experiments within businesses. Like every single day, hundreds of experiments are run based on each of these small intricacies, right? And then you can trigger a recommendation based on the IPI value. Any question? This is very straightforward. Honestly, it's basic math and a little bit of business rules. Any questions on repurchase and interpurchase interval? Okay, cool. I'll move on to the next section. The next one is discovering new brands, right? And this is prescriptive analytics. So discovery is basically you bought shoes, you bought women's cosmetics. What else might the customer like to purchase, right? Why do you do this, right? So you have a shop, right? And you want to be able to sell more products to your customers. You want them to be able to discover more products and therefore sell more products. And you want to be able to show them the most relevant product. At the end of the day, everyone has a fixed amount of time that they're going to spend on your app. So showing the most relevant product makes most sense, right? So based on an analysis I have done in the past, so we saw customer who purchased women's cosmetics and shoes in the past typically also purchase these subcategories, which are hair accessories and women's activewear. So if I have purchased shoes and women's cosmetics, I am most likely to buy, say, hair accessories or activewear. And on the right hand side is an example of how do we measure it, right? We do all of this, we can build the best machine learning model and with the highest accuracy and this and that. At the end of the day, if it doesn't move the needle for the business, it's absolutely useless. The model will be scrapped, the team will be scrapped, and nobody's going to be interested in it. So how do we measure it? So typically when we start a new project or build new models, we do a lot of experimentation. And for instance, for this discovery strategy of personalization, say an email was sent out with discovery brands. And what did we see? Uh, if you look at the bar chart on the right hand side, you have the discovery cohort and the control cohort. What is control? Control is people got some random brands to try out, right? It's not related, or it's no analysis was done. And the discovery cohort was where we build these algorithms and showcase brands that were recommended by our algorithm. And what we saw was two things, CTR and CTOR. CTR is click-through rates. So basically, what it stands for is percentage times the recommendation was clicked versus number of times it was shown. So if my email went to 100 people and 2 people clicked it, then CTR is 2%, right? What is CTOR? CTOR is basically percentage of times a recommendation was clicked for every time the email was opened. So if it went to 100 people, 50 people opened the email, and then 5 people actually used it, then that's 10% CTOR. And from the analysis, you can see that it's actually significantly high compared to the control cohort. CTOR is significantly higher compared to the control cohort. Okay, so that's your discovery at a very high level. And the next, we'll move on to the practical applications through coding. And I also have a slide on exactly what we're going to do. But any questions on this? Any questions on the measurement? Any questions on, like in the real world, how things happen? Anything, data, intelligence application, anything at all? Any question? I can take one or two questions. No, again, no silly questions, nothing. Please feel free to ask anything, absolutely anything. Oh gosh, there are over 100 people and there is not a single question. I find that so difficult to, yeah, it's very difficult for me to believe. Come on, no?
There was one question, but it is not during this time.
Mm-hmm.
There is a one
Sure.
question on
Mm-hmm.
from Ajitesh Moy Ghosh.
Mm-hmm.
He asked, "What is the explanation of positive skewness and negative skewness, and how to overcome it?"
Okay. So I think for that we will have to go to the basics of normal distribution and all of that. I assume because there's a lot that goes around Ajitesh around skewness. So it depends on the data that you're using, right? Like if you are assuming that, again, the test that you're using, is it a parametric test or a non-parametric test? If it's a parametric test, is it a normal distribution or what kind of distribution is it? If it's a non-parametric test, so uh, it's a pretty wide topics, Ajitesh. So and it depends, right? It depends on exactly what kind of distribution, etc., your data is following. But I'm happy for you to just look it up online. Like if you have, again, if it's coming from an experiment or an analysis that you're doing, I would recommend first find out what is the distribution of this. Again, it could be a logistic sort of data. It could be in zero and ones. I don't know what your data looks like, right? I don't know what are the drivers of your data. Is it is there a dependent or independent variable? What kind of method are you using? Are you using a random forest, a tree based method? Because a lot of these methods, there are methods that actually take are able to absorb skewness in the data within, and it doesn't impact the analysis. I don't know what you're trying to achieve here. So, like I said, it's a loaded question. It'll be good to understand. Maybe later on you can drop me a note, or you can send a note to Kari. What exactly are you trying to achieve? What does your data look like? What is the objective? And I will be able to help you. And if you can also share with me exactly what are the different data that you're using and what sort of negative and positive skews you're getting, I'll be very happy to help you. So definitely reach out. But at a very high level, I think it really depends, as I said. Anything else? Anything else from this one?
One more questions from
Mm-hmm.
Imran.
Yes.
He said that your overviews are very good. Would you please tell something about innovation in this sector?
Sure, absolutely. So, see, personalization as a concept. I think when I started out my career, I think a lot of focus was on, let's say, repurchase, right? When I started my career, I was using Excel, right, to build my algorithms. And then we moved on and then we started R and Python. We didn't even have deep learning as a concept, and neural network as a concept has is just so new compared to, we used to run algorithms like very simple linear regression and so on. And honestly, whilst it was a great experience, I don't think the results that we got were amazing. But in today's day and age, and with all these open sources and available, like me being able to use Python free of cost, all these packages free of cost, and being able to utilize all these cloud infrastructure, which are absolutely dirt cheap, right? I think this has come a very long way. And how has this changed is when you now open, say, Netflix or say, instance, any OTT, every time you watch something, your personalization, like pretty much on a real time, it's changing, right? While for users, it's like, okay, maybe now they are used to it and expected, but to be able to do that, there is so much real time data that is being, run and churned, and predictions being generated in the back end, and it's all happening so fast. I think the speed to value has just increased so much. It's amazing. So I think that's one of the biggest thing that's happening. Everything is like so much faster. Like I have run billions of earlier, for instance, Imran. Earlier, we used to run, I'd say 1 million rows or to couple of millions of rows, and my code would run overnight. I would come back and, see the predictions. Now it just happens in a fraction. So I think the infrastructure around all of this has changed. And because we have so much more data now, uh, it's just become more exciting to be able to use all these new algorithms that have also now come because we have these large data. I think that has been the biggest paradigm shift, and it'll continue, is what I feel. And even if you look at, for instance, your social media feed and all, I don't want to name brands, but every time you see a particular type of, say, reel or video, how quickly the personalization is changing for you, and that's happening for hundreds of millions, if not billions, of customers, right? Okay. I will now quickly move on to, and Imran, I hope that answered your question, but I will now, we have 20 minutes. I will quickly move on to the most exciting part, which is the demo, practical application through coding. So we will try and code the discovery part of the personalization, which is basically what we are going to do is we'll have transactional data which we will generate ourselves. Like I said, I can't supply you with actual information, but again, all of you as faculty and academicians, if you have ties with corporates, etc., I will encourage you to reach out to them to give you masked data. They don't have to give you information that is identifiable to people, or give you old data and so on, because you have access to all these algorithms. It's open source. Go ahead, get that, try and see if you can get that data and see what you can build, because everything is available free of cost. All you have to do is just put in a little bit of effort and get those insights out, and it's a win-win situation for corporates and academics. Okay, so the discovery. So what was discovery? I have purchased, a certain category of stuff, or I have listened to these sort of music. What else would I be interested in, so that I spend more time on your app, or I spend more money on your app, and so on and so forth, right? So what we are going to do is we will use a neural network algorithm. It's called autoencoder. Again, I'm not sure this was covered or not. And there's so many different types of neural networks. And there are many ways this problem can be solved. However, I have chosen autoencoder. But having said that, like I said, it can be done in multiple ways. So what is an autoencoder? It's very simple, okay? Excuse me. An autoencoder is a type of neural network which is used to learn efficient coding, or basically it's an unsupervised learning model that will happen. So it has three parts. It has an encoder, decoder, and loss. What is an encoder? Encoder will take our transactional data, okay, and we will strip it off with of all the information that it has. And I'll show you in the code how that works. So we'll strip off all the data, we'll put it through the encoder. It'll take that data, and it'll try and summarize it, right? It'll summarize it, and then what the decoder will do is, from that data, it'll try to decode it back to the real data of what was supplied to it, right? So whatever is the difference between what went into the model, whereas what went into the encoder and what got out of the decoder, will be represented by loss. So the idea is to minimize the loss, right? The lower the loss, the more likely what went into the encoder is same as what came out of the decoder. Why are we using this for this crazy algorithm for discovery? Is basically because what we want to put through the encoder is Ahana bought shoes, and she bought cosmetics, and she bought women's clothing, and she also bought let's say pet food. Okay, so now what what the algorithm will try to do now is that, say Kajari, our IEM person over here, she also bought cosmetics and shoes and something else, exactly what I bought. Because it has encoder has read all of my information, and it knows that other than all these three things I have also bought pet food. It'll use the algorithm then to tell that, hey, this is that extra thing. The probability of Kajari buying pet food is very high. Now that I know pet food is not the best example. Kajari may or may not have a pet, but just for the sake of an example, that is exactly what it's doing, right? So we pull in the data, the decoder tries to decode and recreate that same data again, right? And when I say recreate that same data, that's how we use the algorithm to predict what else can we recommend, and the loss function is what we use to see how accurate it is. So I'll quickly stop sharing and share my screen back. Just give me a moment. Okay. Okay. So I'll tell you how I did this. Again, I am assuming that everyone has some basic level of understanding of coding. If you don't, that is fine too. What I'm using here is VS Code. VS Code is Visual Studio Code. It is available free of cost for anyone. If you have a Windows laptop or a MacBook, which is what I have, you can download it and use it. You can use Python in it. I'm using a Jupyter notebook and basically a Python Jupyter notebook to run this code. Uh, Again, I won't get into the details of all of these different packages. I believe you already know that. So we read through different packages and so on. So what I've done in this section here is that I am building my data set, right? I'm building again because I'm unable to provide raw data. But having said that, if you guys have access to raw data of different kinds, you can follow a similar way of solving this problem. So what I've done is that I have introduced subcategories here. There are 12 different subcategories: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 different subcategories. You can have 30 or 5, whatever you like. I have also like randomized some dates because different customers will buy different things, and also customer IDs 1, 2, 3, 4, 5, and 6. So I have uh, built this raw data set, which kind of looks like this, right? Customer 1 looks like this, customer 2, and it, let's see. Yeah. So this is what the final data, I don't know why these notifications keep coming, sorry. So this is what the data looks like. So customer 1 bought jewelry and women's clothing and all these dates and so on. Okay. Um, and then uh, remember I said that we strip the data of any information because that's what the input into the encoder goes, and that's how the model works, right? We are the reason why we're stripping it off, it becomes a very basic model then, and it makes it very easy to analyze that information, and it makes it very quick and efficient to analyze that information. So what I've done is I'll show you what it looks like. Let me see. First, let me also have a look if the subcategory. Let's see if there's a yeah, there's a subcategory. So just before I go to that, this is the subcategory list. In Python, it always starts with the index starts with a 0. And if you are an R user, it'll always start from 1. But anyway, so there are 12 subcategories, and that's why it says 11 because it starts with a 0. And then once you strip this data, this data, customer one, all these different subcategories of all the information, it will look like, oh gosh, it will look like, it should look like, let's see, yeah, not this, wait. It will look like this. This is the data that goes into the model, right? So if you look at index one, this is customer one, and all of these are subcategories. Uh, so there's a method, it's called one-hot coding. One-hot coding is basically when you convert the data into a 0 or a 1, right? So if this customer bought subcategory 3, it'll be a 1, and if she didn't, it'll be a 0. So we can validate that also. So this customer bought subcategory 3, 4, let's say 3 and 4, right? Customer 1 bought subcategory 3 and 4. So if you look at the data here, let's see what is subcategory 3 and 4. So it's cosmetics and fresh produce. So if you go back to the data, customer one, she bought cosmetics, she bought fresh produce, right? She also bought pet supplies and hair and makeup and jewelry. So let's see, pet supplies is 8, hair and makeup is 6, 6, 8, and jewelry. So, oh, 6, 7, 8, right? So let's see. Yeah, 1, 1, 1, right? And she also bought 11s. What is that? Women's clothing. Let's see. Yeah, women's clothing also. So I hope it's clear what it's doing to the data, right? So it's like a 0, 1 matrix that is going into the model. So once that is done, there are just some steps that we have to follow, which is, we have to transform the data in the format that the model can read. So we are just doing that in this step. So we are preparing the data so that can be used to train our deep learning model. And then we take all the customer purchase histories and pack them into a data set. Sorry, I'm just reading out the notes that I've written here. We feed them into the model in small shuffled batches, right? So if you look at DF, it has how many rows of data? So it has 553 rows of data. How some of these models work is that not all 553 will go at a time. They'll randomize it, and maybe 300 will go at one go, or 200, depends on, this is a very small data. Typically you will work with tens of millions, if not hundreds of millions of rows. So it takes a subset of the data, and the subset can be at a customer level subset or subcategory level subset, and you can define all of that based on your strategy. But that's the idea, right? It'll take these different subsets, it'll collate it and run multiple iterations, and that's how basically neural networks work. So once that is done, sorry, I'm looking at time. We have 7 more minutes, which is great. So once that is, once we run the model, this is where we are actually, sorry, once we do that, this is where we actually run the model. There we are just deciding, like, how to randomize. In the previous step, it's more like how to take these different subsets of data that will go through the model. And then in this is where we actually train the model. This is where it actually calculates the losses and so on. And the way losses, basically, it's calculated, it's basically, in layman's term, how if customer one bought all these different subcategories, what is the outcome? Are we doing, like, say 5 out of 5 all correct, or is it 4 out of 5, or whatever? So every time an iteration is done, so we've run 30 iteration, and as you can see, as the iterations are running, the losses are kind of going down. So the more you iterate the model, the more it'll go down. Again, the more you run the model, this just has 500 rows. Having said that, if you have tens of millions of rows, sometimes you'll also have to, rationalize whether you want to run it 30 times, or do you want to run it 100 times, or do you want to run it just 10 times? Because every time you run an iteration, it is a function of time, it is a function of resources, right? It is a function of, how much you're paying to run these models, how much infrastructure you're using, and so on. This is obviously a small example. It's running on my local laptop. But if this had, say, 10 million rows or 100 million rows, I wouldn't be able to run it on my laptop. I would have to get a virtual machine with very high specifications to be able to run it. So anyway, so it's done this iteration. And then it's just giving you the recommendation based on this iteration, right? So I will show you what that will look like. Um, yeah, yeah. So basically what we're trying to tell the model is how many recommendations do I want and what should my output really look like? I should have the customer ID, I should have what they purchased in the past, the subcategory, and do I want top 5 or top 4? And you can make these changes and so on. And when you see the output, you'll be able to appreciate what we are doing here. Um, and if you think about it, the heavy lifting has actually been done by the code. Like you really, I mean, you can get into the weeds of things or what's happening, but at a high level, like, if there is a mock data or if there is like some basic data you have, this is a good starting point to run your model. You can always tweak it. You would have heard of terms like hyper parameterization and all of that. All of that can be done, but there is a starting point of something. This is a good starting point, starting with defaults and then tuning your model based on your data. And I think a few people mentioned about skewness, this, that. If you foresee that some skewness, see if you can filter out some data and so on and so forth. But this is a very good starting point to start your modeling. Like you have to start somewhere. A lot of times we say 80-20, right? In a business, let's not spend 80% of the time to give something that will give us 20% value. In businesses, we say fail fast, right? You have your data, let's run it through it, let's see what outcome we get, as opposed to making the most beautiful model and the most accurate model with the best parameters and then wait for 6 months and you still haven't figured it out. No, you have your data, you build something in 2 days. Let's see what it is. And then go from iterate and pivot and so on. And that's the way typically in the business we operate. Anyway, so now if you see the output here, um, so you can put the customer IDs here. The customer IDs are basically the index values. So if we say choose, no, sorry, it's not these index values, my bad. It's basically the IDs, customer IDs. So 1, 2, 3. However, the way it is done is that customer 0 is basically customer 1 and so on. Like I said, in Python, it's a bit confusing, unfortunately. So when I write customer 4 here, it's actually customer 5, which is this customer. They have bought all of these things: cosmetic, shoes, hair, makeup, garden, beverages, fresh produce. Let's see what it has to recommend. Yeah. So they have bought all of these things. So it's created some sort of a probability or, a code of score saying that maybe auto is highly, recommend. Again, like I said, this is a mock data. The outputs may or may not make a lot of sense. It's also very little data. Typically for neural networks, you don't use 500 rows of data. You will use at least 500,000 or 5 million rows of data. But again, this is just an example of how, with the data that we had, we made use of neural networks to give us insights and recommendations that actually gave us a CTOR, which was significantly higher than the control group, right? So like you can see recommended subcategories, it has like 0.64, 0.44, and so on and so forth. So you can decide maybe you want to show both of these or any one of these. You can have a threshold in terms of the scores, maybe anything above zero point 0.4 you want to show, so all the three, or you only want to show anything above zero point 0.5, so that then obviously you'll choose auto. I'll just give you another example. Let's just write 10. let's see what it shows. Oh gosh, this person has bought so many different things already. And again, seems, again, if I was in the business and say this was good data, I'd say maybe not show them anything, because point 0.3, if I have a threshold of say point 0.4, then I will not show them anything, right? Maybe I'll focus on substitutes and repurchase. Alternatively, if everything is very low for them, I could have an experiment. I can run a side experiment with all those customers who have low scores for their recommendation, and then try to show the top one and see how they respond. If in that experiment I see that the CTOR is actually not that high, then maybe it proves my point that it's not worth showing discovery recommendations to customers whose scores is low. So why should I spend that money and infrastructure and efforts to show them uh, these recommendations? So again, I have shared this code with Kajari, this exact code. You can replicate it, you can play around with it, you can tune it yourself, you can change different things with it, and definitely give it a try. It is a popularly used code, I would say. And if you have any questions, please reach out to me. I will stop sharing this screen now, and I will go back to my slide. Maybe I just have it here. Cool. I know we are 1 minute above our time. However, if you have any few last questions or so on, anything about my experience you want to know, anything else which was not part of this deck, if you're intrigued or have any questions, please feel free to ask me. And like I said, I'll be more than happy to take your questions, even offline. If you want to send it through Kajari, please feel free to do that. If you want to stay connected with me, please feel free to do that. Thank you.
Thank you.
Thank you, Ahuna, for this wonderful session. So, um, we will like to continue with our session 2. For this second session, we would like to call Dr. Devashish De, is a professor in the Department of Computer Science and Engineering in Maulana Abul Kalam Azad University of Technology, West Bengal, India. A senior member of IEEE Fellow of IETE and life member of CSI, he has received prestigious awards such as Biocast Fellowship, Endeavour Fellowship from Australia, and Young Scientist Awards from 2005 and 2011. He was honored with the J.C. Bose Research Award in 2016, Shiksha Ratna Award in 2019, and IETE Chartered Engineer for his contribution. With over 400 plus journal papers, 200 plus conference paper, and 20 books and 4 patents, 4 copyrights. He has lead research project funded by AICTE, UGC, DST, World Bank, AWS, and METI. He has held leadership roles as chairman of CSI, IETE Kolkata, and EC member of IEEE ComSoc Kolkata. His H index is 50 with 12,000 citations, and he ranks among the top 2% of global scientists. Currently, he serves as associate editor for several reputed journals, including IEEE Access, Springer MST, WeLead IGCS, and Elsevier IET Quantum Communication. His research focuses on edge intelligence, IoT, and quantum computing. Welcome, sir, and you may start the session now.
Okay, very good afternoon. Good evening, actually. It's almost 7:30. And thank you for giving me this time. And today I'll just discuss some of the topics related to data science for Internet of Drone Things from classical to quantum era. As you know that we can see the drones around us and all the newspaper on the news channels, and this technology is almost 70 years old because of autonomous drones. And this, you can see the multiple drones, they're connected to each other. So, and they're connected, not only connected, they're controlling each other, right? and they're exchanging the information among themselves. And that's why this is called Internet of Drones, because one drone can control other drones and exchange the information. So during the talk, if you have any question, you can ask me directly. You can unmute and or you can send a question, say anything, and so that we can give the answer instantly, right? So where you can see this multiple drones. I think how many drones are there? 12 drones, right? All the 12 drones, one drone can control the others and communicate, rather exchange the information, and various data related to uh, smart cities and agriculture and everything. And drones are so popular, and it can carry the images. It can take the images. It can take the video. It can take the any kinds of multimodal data. It can access. That's the reason that drone computing, especially Internet of Drones, right? We know IoT. Why call it Internet of Things? Where now we are calling Internet of Drone Things, where the extra D is coming, Internet of Drones. But drone is coming as a picture, where multiple drones are coming together and computing and performing exchange of data, right? So this is the agenda for today's discussion. We have 4 agendas for next 1 hour. First IoT, then drone security, then the data science and the machine learning techniques for drone privacy, and second one is quantum drones, quantum Internet of Drone Things. As I've already mentioned, that these drones can exchange the information. So drones can be anywhere in the world and anywhere in the city, and they can exchange and communicate to each other. If any one of the drone is failed, other drone can come and take the part and perform the action, right? And that kind of coordination and communication and exchange of data is there. That's why we are calling it Internet of Drone Things, right? So as you know that drones has generally 4 wings. We have rotor and stators, like the BLDC motors. I think everyone know the BLDC fans are very popular in our homes nowadays. Same motor is used for access controls or data exchange information. And in the drone weight is, actually moving, giving the weight downwards the ground. And these wings, the 4 wings, the wings actually give the thrust on the sky. And if the wing thrust is higher than the weight, then the drone will move on the sky, right? That means when the lift is greater than the weight, the drone will move on the sky. When this lift is equals to the weight, then hover. Hover means stand still on the sky. So two moves in clockwise, 2 in other anti-clockwise. That is the aerodynamics part, how these drones flow on the sky. Nowadays, these drones can carry the human being, and for example, Bombay to the seashore to the ships. Drone can transfer the human being, but it can carry around 130 kg. So more thrust we need, we have to give more wings. For example, this drone has around 8 wings, and which can exchange the information, and we can give more thrust on the ground, and it can carry more weight, right? Huge amount of weight it can carry. Okay. So drones are now there's maybe in future you'll see drone taxi will be there, drone Ola, drone Uber, drone Jatri Shati. When these kind of things are coming to very soon. So these are the facilities we are getting, and these drones are actually nothing but edge devices, right? So everyone uses cloud computing, right? Cloud is we are using cloud. Say Gmail is our Google Drive. Everything is cloud, right? Now we are having edge devices. Edge means the devices which is actually billions in number, but it's very close to the human being. Say the Amazon cloud is in Mumbai, Ahmedabad, or anywhere in Bangalore. So we cannot see the cloud nearby you. You know, to transfer the data from the sensors, for example, your smartwatch, it can capture the atmospheric temperature, humidity, and if the processing is done at the cloud end, it will go for a lot of delay. But nowadays you can see that our phones has a lot of RAM, right? How many? What is the GB RAM we have now in our mobile phones? Can anyone say? 8 GB. Anyone has 8 GB RAM in your mobile phone?
Yes, sir.
8 GB RAM.
8 to 56.
Yeah, 8256. So you understand that earlier it was not there, right? Nowadays, your mobile phone can compute huge amount of data, isn't it?
Yes, sir.
As a result, we do not need to send always the sense data by your smart watches or smartphones to the cloud. We can compute within the device, right? Within the device itself. So this is known as edge computing, computing at the edge. Because we have 8 by 256. That means 8 GB RAM and 256 hard drives, right? We can compute in device computation. Within the device, we can compute. So data should not go travel long distance. If we can compute at the edge, we can perform it very easily at the edges. And we have billions of edge device because every user, India has around 146, 147 crore people, right? Where almost everyone has mobile phone. At least 100 crore mobile phone is available. Yes or no? 100 crore out of 150 crore, right? So almost everyone has mobile phone nowadays. Even I have seen many people has 2 mobile phone, right? So we are computing everything, our health data, your BP, your smartwatches can measure your heartbeats, pulse, even pulse, oxygen level, saturation, everything in the edge devices, edge level. And we have billions of edge devices around us, right? This is actually the cloud fog edge network. Thousands of clouds, but we have billions of edge devices because everyone has mobile phone, right? Almost everyone has smartphones, many people, at least 10 crore people has either smartwatches. It is affordable. Earlier it was very costly. Now it is below 1,000 rupees. The smartwatches are available, isn't it? So it can compute a lot. Smartwatches can compute a lot. So this is the edge computing. Your drones, they're also edge computing. We can compute within the drone itself. So these drones also we can compute within the drone. So it is also known as drone edge computing, or we are giving drone as a service, right? In cloud, what do you see? Platform as a service, software as a service, infrastructure as a service. Similarly, drone as a service. Okay, we can perform the subscription basis. We can use the drone. We call it drone as a service or DaaS. So, what are the key components of drone as a service? We can access the drone hardware, software, remote piloting or autonomous piloting, data collection and delivery. These are all done by the drone itself, right? And there are huge benefits of DaaS: cost-effective, scalability, faster deployment. So these are the advantage of drones. Right? So in the drones, we are using LiDAR. What is LiDAR? LiDAR is for light detection and ranging. Light detection and ranging. So it is used for remote sensing. Now we are using this drone with the laser lights. So what is happening? So when the drones are connected with the LiDARs, it can do tomography, 3D mapping of the geospatial data, right? For a camera, only can see on the top of the trees. But if you use LiDAR, it can go down, it can penetrate, and it can go up to the ground. So we can get the exact ground surface image, right? So LiDAR is very powerful. Almost it costs 1 to 2 lakhs or 5 lakhs range for these LiDARs, right? These are the very powerful laser technology we use. LiDARs. LiDARs are very powerful for 3D mapping. And these drones, actually, we are using these LiDARs. Generally, these bridges, which requires a lot of maintenance cost. Earlier it was sensors are installed within the bridges. Nowadays, using these drones, using the LiDAR, it can simply scan the full bridge by using a single or maybe except 2-3 drones are enough to find out if there is any crack in the bridge or not, right? So this is the advantage of using LiDAR technology. It is saving thousands of rupees. So instead of installing the sensors in every point, we are using this LiDAR technology. So using this data science, I'm listening to the previous lecture. So a lot of Python code and everything is been given. So we can get the data, we can extract the data from the bridge, and we can measure the health monitoring of the bridge using these LiDARs. right? Even the chimney crack monitoring, the chimney, difficult to find out the cracks or not. So chimney crack monitoring is also possible using this LiDAR technology. Even if you have seen the James Bond movie, the cars, where it comes with various camera, light, and everything. Nowadays, also Tesla car, they have this kind of parking assistance. Not only, I think everyone has seen the parking assistance in the back only. Nowadays, we are using LiDAR, drone camera, everything is coming together, right? So also it comes with radar. Radar can reflect the target, right? So radar can reflect the object, it can presence, we can find out the presence of the target. So if we can install this kind of radar, camera, LiDAR within the drone itself, so Internet of Drones becomes very powerful. It can find any object at any distance. That is the reason we are using this kind of high-end radar, which is installed within the drone itself. And it's very popular for military applications and surveillance applications. On the border, on the Siachen, the temperature is very low, right? We can use this kind of radar for border monitoring and border maintenance so that the enemy things can be found out easily, right? So another radar is called synthetic aperture radar, which is very popular for this kind of measurement, right? It is installed within the in the bottom of the aircraft, and it is called synthetic aperture radar or SAR. SAR is very popularly used for imaging purpose, image tracking. Nowadays, we are using the fusion of camera, radar, and LiDAR together. So it's the fusion technology. Nowadays, in the age of information fusion, there's even a journal Elsevier called information fusion. So a lot of things are happening for intelligent fusion, where machine learning is playing a major role for intelligent fusion of camera, LiDAR, and radar. They're coming together and performing the operations. Here. So if you see this smart city also, these drones are playing a major role where 1, 2, 3, 4 drones are there. They are managing the whole city, humanless. So the traffic control, the drone can do it. If someone breaks the signal, see this picture, drone is go and take the image of the person who is sitting in the car and send the ticket. Ticket means the fine, right? So total city management, traffic management, fine management, everything is done by the drone itself. Autonomous drones, right? No one need to give instruction, it can perform automatically. So for home also, drones can act as a drone doctor. They'll go to your home, attend the patient, and come back. So you have to register to a certain hospital. Then only the hospital will send the drones. Suppose Apollo is there and Medica is there, Manipal is there. So many hospitals are there around us, right? SSKM is also there. So we'll send the drone, and this drone will come and give the service to your parents or you, if required, right? So drone is also acting as a doctors. Now see, this drone to drone, they are all connected to each other. That's why we are calling it Internet of Drones. One drone, if suppose this one fails, this other drone will come and give the backup. So that's why hundreds of drones are actually monitoring the city. Instead of deployment of human being, we can deploy the drones in the cities for efficient data management, efficient monitoring, right? Now drones are flying in the air, right? We are working on the ground, but drones are flying in the air. They are landing in the air, right? What they are learning? How to fly without any collision. How to exchange the information efficiently from one drone to other drones. How to fly as a group, like a flock of birds. We call it PSO, GSO. PSO means particle swarm optimization, global swarm optimization. So this is actually the edge learning. Learning is happening in the air because drones are flying in the air. Very simple, and everything is happening in the air. So drones are learning in the air how to fly without any collision, how to fly together, how to exchange the information. These are the very important factor. This learning is nothing but machine learning. I think everyone knows what is machine learning. So this machine is learning, means drone is also one machine, right? It is also learning to reinforcement learning and various other learning techniques, how to exchange or extract the information, how to gather the images from the land using the camera. So everything is landing in the air. So it's landing in the air. So that's very important. They can fly like a bird. While the birds are flying, they never collide. So we have to follow that kind of bio-inspired algorithms to install within the drone itself so that edge learning becomes efficient and systematic, right? So as I mentioned, drone is nothing but edge computing, and you have to give the intelligence to the drone. We call it mobile edge intelligence, where mobile edge computing and AI will work together, right? What is this? This is a book on mobile edge computing. What is mobile edge computing? The multi-access edge computing, where actually computation happening in the edge. So this book is on edge computing because drone is mobility. Drone has mobility, right? Drone can move anywhere. This book is talking about how this mobility is happening in the edge, right? Edge computing. How this computing is happening at the edge. The second one, how this AI is coming on the IoT. So edge AI. So this two book is, first book is all how to develop the edge computing architecture. Second book is how to provide. This is how we have written 2 years before. How to provide intelligence with the edge devices, right? Now, this edge intelligence has 3 levels: centralized intelligence, local intelligence, and terminal intelligence. Centralized means the cloud has centralized intelligence. Cloud is very powerful, has huge amount of servers, so huge amount of computation capability. But your 8 GB phone has limited, comparatively limited capacity, isn't it? So this is known as terminal intelligence or edge AI, intelligence at the edge. So we have to use lightweight version, right? Lightweight intelligence. So the 3 levels: centralized intelligence, local intelligence, and terminal intelligence. We have to use lightweight intelligence within the drone terminals so that the computation can be performed very easily and effectively, right? So in the edge devices, we are providing lightweight edge computing. Means machine learning also with lightweight. Deep learning, the lightweight version of deep learning. Or even federated learning or local intelligence, right? So this is very important. We have to, this is known as terminal intelligence or edge AI. Edge AI. Edge AI is one of the most popular, what I can say, the research topic in the year 2025. Because, we have to develop the various interesting technologies for this kind of operations, right? Now, as you can see, the drones are autonomous. For last couple of years, we can see drones can perform the all operations automatically. They can see someone is lying on the ground. They can give the call to the ambulance. If something is called fire, they can give the call to the fire brigade. So no human being is involved. Drones are performing the whole operations, right? Like a bird, it can fly, and it is giving support to mining to infrastructure everywhere. Drones are providing the service, mining to infrastructure, agriculture, huge amount of application, transport, security, insurance, telecommunication. The agriculture field, drone can exactly provide the pesticides to the affected field zone areas, right? Yeah. So we are not giving the pesticide to the the unaffected areas. We are giving only to the precisely. We are selecting the affected zones to the camera, and using image processing, we are detecting which one is the affected area, and accordingly, we are providing pesticide to those areas only, right? So we are providing volume, velocity, and variety. 3 levels of V's are there. Volume, velocity, and variety. 3 V's. Right? Now you can see these drones are, the comic picture. Drones are gathering huge amount of IoT data. IoT, Internet of Things data. So when drone is coming with IoT, it becomes very powerful. Right? It becomes very, very powerful. See, this IoT, we can see that this elephant is flying on the sky. Elephant is flying on the sky means huge amount of data is flying. So it is almost equivalent to elephant is flying, right? So drone can see, and simple example. Earlier we used to use hard drives. Now we are using solid state drives. SSD. Everyone knows SSD. In our laptop we use SSD. If you use SSD, it can carry several TBs of data. So it is like elephant. Huge amount of data is flying. Just comic picture, but for better understanding, I have given it that it can carry huge amount of data. So drones are like a Superman because it is performing all kind of operations in the borders, agriculture, and everywhere, whatnot. So when you're talking about drones, drones are not only in the on the sky. So we have to cover internet of drones, means internet of everything. We have to cover on the sky, on the land, also under the water. Right? So under the water also we are providing service underwater. So we call it UAV AUV network. UAV means on the sky, AUV means underwater. Aquatic underwater vehicle, unmanned aerial vehicle, aquatic underwater vehicle. So these are the UAV AUV network through which we are connecting the drones under the water, also above the sky, and both of them are exchanging information together to make a meaningful collaboration in the field of Internet of Things. So PwC made a forecasting that what will be the characteristics of a drone. They can fly by themselves, they can crawl, they can talk to each other, means exchanging information. They can recognize the face, can climb, grab the objects, and delivery. Or grab the objects means delivery of products. They can give each other space, means transportation, means without collision, drones can fly on the sky. So these are the characteristics of Internet of Drones. It was forecasted 2016 by PwC. Now everything is happening together nowadays in 2025, 2026. You'll see that Flipkart, Amazon, they will deliver the products through the drone itself, right? Even in deliveries of tea, coffee, everything can come like this, right? From Starbucks or everywhere, right? Maybe the organizers will arrange the coffee for all the participants. Any tea break is there, sir? So you can arrange. Maybe in future we will arrange this kind of tea breaks where we can deliver the products, everything through the drone itself. And tea delivery, coffee delivery, Starbucks is very common in various countries like Australia. They have used. If you search on YouTube, you'll get it. Birds, I know that sometimes there's a collision with the birds. Otherwise, coffee delivery, tea delivery, the food delivery is very common. In India, we have also delivery of medicine in Arunachal Pradesh, in the hill areas, in the Sundarban area, means jungle areas, where we deliver the food packets and also medicine essentials through this object grabbing technology, right? So that the drones can pick up the object and deliver the object. Right? So we also develop certain model for this drone delivery. Now, generally, these are the research challenges, right? Routing challenge, mobility challenge, resource allocation, power, privacy, and security. So I'll talk about privacy and security in details today. Where I have mentioned already, edge drone means drones are acting as an edge device, right? So we are using the protocol called MQTT. MQTT is very common protocol for IoT. It works in the PubSub model. Publisher is one drone, subscriber is another drone. MQTT is the broker which connects one publisher to broker, broker to subscriber. They are communicating to each other, and by this way we are exchanging the information from publisher to subscriber. This is QoS0 model. QoS0 is basic. You see the advanced model, more connections we are getting, more reliable connections we are getting here. Similarly, for QoS2, we are getting multiple, 4 more connections, acknowledgements also we are getting. So these are more reliable data. Just like you go to any hotel, so you want to book a basic room. Basic room is QoS0. Only there will be what is the basic facilities like bed and one fan. If you go for deluxe room, you will get more connections like AC will be also there, right? If you go to super deluxe room, more reliable connections like maybe fridge will be there, maybe other facilities will be there, right, in your room. So that is the difference between QS0, QS1, and QS2. Obviously, QS2 is a little bit costly because the publisher to subscriber will pop sub model. Pop is one role. For example, in this FDP, I'm the publisher. I'm speaking here, right? I can see 250 participants. They are all the subscriber. So they are the subscriber. So one publisher, who is the broker here? Can anyone say? Anyone or any organization is here?
Yes, sir.
So just tell me who is the broker here? I am the publisher. And we have 250 subscribers, right? 250 plus I have
Yes,
seen.
yes,
Who
yes,
is the
sir.
broker?
The organizers are broker.
Exactly. You are the broker,
Yes, sir.
right? Broker is
Yes,
not bad. Broker is actually, see, I do not know this 250 participant, right? Because it is the
yes,
auto FDP and you have
yes.
arranged it and 250% joined. They are the subscribers, right?
Yes, sir.
And you arranged it, right?
Yes,
You
yes,
talk to the various publishers, various speakers. Before me
yes,
also there is one speaker. So multiple
yes, sir.
speakers we have seen. So this publisher, they're connecting to the subscriber with various grades, right? Yeah.
Sir,
So this is known as POP
absolutely,
sub.
sir.
So this is known as POP sub model, very popular model of IoT. POP sub. POP means publisher, sub means subscriber. Here we have one publisher, multiple subscriber, and one broker. One broker, why I'm telling you? Because maybe I'm the same person, maybe other college or other university arranged this auto FDP, then the broker will be different, isn't it? Instead of IEM, it will be different college, right?
Right, right,
Different
sir.
broker.
Yes.
So this is a broker. Broker is very good. Broker actually connects the two zones together, right? See, broker is very efficient. See, you arrange those, what is that? Meets, that, what is that? The links, right? Zoom link or team link, right? You took
Yes.
the pain to subscribe those links and you took the pain to, conduct this FTP at almost midnight, this evening, 8
It's
p.m.
like, sir,
Yeah,
it's like we facilitate the system so
exactly.
that two parties can communicate.
Exactly. Same thing happens to the broker. You want to purchase a home, you go to the broker, you tell, I want to have a 3 BHK flat and my budget is 20,000. I want south facing flat, right? And broker has the information where this budget and this thing will fit to you, right? Best fit to you. So they will fit it accordingly, right? For example, during this FDP, auto FDP, you arrange, you have flyer, madam. There's some title of the FDP. Must be some
Yes, sir.
title.
Yes, sir.
So
Yes,
that
sir.
title and with the speaker list you floated somewhere on auto website or all over India.
Yes, yes, absolutely.
So
In
after that,
LinkedIn also
yeah,
everywhere.
LinkedIn and various
Mm,
social
mm,
media. So
mm,
you attracted those subscribers, those
mm.
250 participants, right?
Yes, sir.
Because see, history person is not here.
Mm.
Subscriber means the person who like to attend and gain some knowledge in the field of data science, right?
Yes, yes, sir.
So not all the people, the interested people in this domain, they are attending this auto FTP, and you are acting as a broker. You are
Mm,
giving a lot of facilities, and maybe you
mm.
will provide certificate, you will take exam or so many things, right? And
Yes, sir.
accordingly, you are conducting the whole session, taking the pain of whole week, right?
Yes, yes, sir.
So you are actually the acting as a broker. And see this connection, see connections, acknowledgements. So acknowledgement means the any problems. I think subscribers are contacting you, isn't it?
Right, right, sir.
Right?
Right.
You have to take a lot of pain, whether you're joining or not, whether you're giving exam or not. Right? So many
Attendance, everything.
attendance, feedback, a lot of formalities.
Yes,
See,
yes,
see,
sir.
this is also see acknowledgement, feedback, establishment of
Yes,
path. So these are the paths actually. These are
right.
the 5 nodes or 6 nodes which is taking reliability. So can you see this is a QS2 means good quality service. But if you go to QS0, only connect and publish. Only connect and publish. That means a hotel with only fan and only one bed, right? common bathroom, right?
Right.
But see, this is the more good quality. That means deluxe room, AC room with attached bathroom, right? Publisher subscriber. So you are getting little bit better service. And this is super deluxe, or you can say that royal kind of room where you're getting all the connections. Right.
Absolutely, sir.
So I just want to give an example like this so that everyone can understand at least. It's a critical subject. So this is actually IoT. IoT, in the field of IoT, there is always a broker who connects the publisher to subscriber. Right? So one drone to other drone, they are the publisher subscriber model, right? Same thing happens. You know that in a college, university, they have certain subjects, BTech in computer science, BTech in IT, and this and that. So they are actually the broker, right? They are providing certain services, and publisher, those are the teachers here, and subscriber is the students. They come and give the service. So this PubSub model works very efficiently in a whole system. So there is one publisher and multiple subscribers, 1, 2, 3, n number of subscribers. Now, very simple. Your team, how many things support? How many subscribers support, madam?
In teams, 1,000 participant can join.
Excellent,
In
excellent.
yeah, yes, sir.
So n can be 1,000, right? 1 to n. So
Yes,
maximum
sir.
n means 1,000 can be. So this is called scalability, right? So 1,000 means you have paid a lot of money, right? Isn't it? There are also subscription for 100.
Yes,
There is a
yes,
subscription for 500 also. I know it very well.
yes, yes, sir.
So you paid a lot. Why you paid a lot? Because you can accommodate more person, right?
Absolutely,
Suppose
absolutely.
suppose you are arranging this FDP and your team connection maximum capacity is 100. Then it cannot allow this much huge amount of people, right?
Right.
So this is called scalability. This is called scalability.
Yes, sir.
It can be 100, it can be 1,000, it can be 10,000 also. If you pay more, 10,000 people can join, right? During
Yes.
COVID time, you know that times just the Zoom COVID this thing started. Some of my FDP, you cannot believe that 1,000 people joined. 1,000. So after that also we are getting a lot of people cannot join that time, right? Because the it was over flooded.
Yes.
So because there is a upper limit. So this is called scalability, right?
Yes. Yes.
So suppose you are in your BTech class, you have 60 students, right? Next year you think, okay, I'll make it 240 or 180. Then you have to give bigger room to accommodate more students, right? So this is called scalability. And this is the publisher node. Can you see publisher node? These are the subscriber node. This is called pub sub model, right? Same thing happens here also. The pub sub model. These are some of the pictures of a ground board. This is the controllers. This is the drone itself, and this is the hexacopter. See, hexacopter means more powerful compared to the four weights, right? The 6, it can carry more weight, right? And this is the underwater drone. This is in my lab we have. It's an underwater drone. Actually, it is in the IM college. I think have you seen it? Madam? It is in your college. So it is in your college where you can see this underwater drones. This one is the uh, camera, and these two are the lights. And when the drone is going under the sea, you need to give illumination through the lights, and this is a camera. So we need very high resolution camera, and IP means IP65 means underwater means water protection, so that we can give protection to the drones very efficiently and easily, right? So we have modeled something uh, called underwater modeling of edge drones using software defined underwater things. We work extensively in the underwater areas for various modeling, because underwater is challenging, because air density is not one, it is water, so a lot of pollution is also involved. So image processing is also challenging, communication is also challenging. So that's the reason, see, we are using cables. See, can you see these cables? Drones are coming with the cables.
Yes, sir.
But see, normally on the drones on the sky, there is no cable. They can flow automatically, right? Because of that underwater lot of communication problems, so cables are used. Optical fibers or these cables are used. So it can go limited range, right? Maybe 200, 300 meters, or maybe maximum 1 kilometer. Based on the length of the cable, we can see. So that is the limitation of underwater drones, right? But underwater is very important because we explored almost everything in the on the land, but underwater 70% is under the water. So many unexplored flora and fauna is there. So we are having a workshop on data science. Actually, the main data is under the water, right? All the flora and fauna is there. So that's why underwater drones are playing a major role to understand the ecosystem under the water, right? So also we did some work on trajectory controls for if there is any wind, how to tackle the winds. We did some wind management technology. How to, when the wind will come, we have to give the opposite direction force so that wind can be mitigated. Generally, the wind speed is 4 meter per second or 6 meter per second. We have to give the opposite wind, I mean opposite force through the drones, so that we can minimize the effect of wind effect, right? When drones are flying on the sky. Otherwise, what will happen? Drones will land in other place, right? There is a Kishore Kumar song, that is Chate The Chapan Pahunch Gaye Chin. You know the song? Very popular song. Hello?
Yes, sir. Yes, sir. We heard about this song.
You heard about it?
Yes,
Jate
sir.
The Japan Pahunch Gaye Chin means due to the wind, the drone will not land in the proper place, it will go to some other place, right?
Right.
So that's why you have to do the wind correction. So this paper is all talking about trajectory correction, how the drone will move on the sky and they can reach to the destinations. Right? So this is the very challenges are there. You can see wind is mitigated by the MQTT. I already talked about MQTT, right? Broker. Here publisher drone is tackling this software-based wind data control and predicting the trajectory and accordingly changing the location based on the software. Extra opposite power, right? So these are the various winds. We took the data from windy.com and these are the wings actually. Winds, various places. And based on the wind in the various geographical location, drone will give the opposite force. You can see 4 meter per second, 15 meter per second, 40 meter per second, 40 meter per second in the coastal areas like Digha, Puri, those area, or any sea beach area. Generally, wind flows very fast. But in Calcutta, proper city, 5 meter, 10 meter is fine. Right? So we did a lot of aerodynamics. We have, there's a lot of data sciences involved, right, for aerial data. So we took the data from windy.com. There is a very popular website, windy.com. And from that website, actually, we gathered, we captured, and we processed the data accordingly, right? So, see, I think you have seen this in very simple in Operation Shidur, right? By various TV channels, right? When the opposite country drones are coming, we have to expose and we have to destroy this kind of drones done by this kind of uh, anti-drone technology, anti-drone gun, which will actually diffuse this kind of drones, either destroy or diffuse using high frequency and high power jammer, right? Also, there are some drones are coming called spy drone, very small, like a mosquito. You see it on the, you can also attend this kind of workshop, right? If you want to attend, right? So you will go to any place, enemy place, take the camera. There's some camera in, and also a lot of sensors are there. Hundreds of sensors are there. It can fly nano electronic mechanical system. That can fly and it can capture the data. Some countries like Israel, China, they made it, right? Even they can kill also. They can inject the poison. They can kill the person. Dangerous. These drones are very dangerous, called spy drone or nano drones. Right? Sizes like mosquito size. It can fly long distance also. So we take the help of, have you seen it? Glowworm? Anyone has seen? Jonaki poker? Glowworm.
Yes, sir.
So when the glowworms stay together, do they collide and fall on the ground?
No,
No,
no.
because they know how to fly on the sky without any collision. Light is the thing. This light will allow to keep them different. Otherwise, what will happen? They will collide to each other because they cannot see on the dark area, right? That is the reason nature has given light. Clear? Now, what we did, we gathered the knowledge of this glowworm and we modeled in MATLAB and so and so. And we modeled it how to fly and various rounds. And we implemented in flying ad hoc network, FANIT. So, FANIT means how these drones will fly on the sky, but without any collisions. Normal collisions, right? Movement means scores. See, there are various movement. RGSO means glowworm swarm optimization. See, glowworm swarm optimization. We did some of the works. How this movement can be controlled. Limited movements. We have also used fuzzy drones for glowworm. We have used various kinds of sensors and technologies working together. Okay. Now, for drone mobility, we have to find out what is the speed, what is the direction, and what is the angle drone will move. So these are the patterns, movement patterns we have to find out. Using big data analytics, we have to, again, this data science will come. We have to find out how the drones will flow in the windy zones and non-windy zones and also polluted areas. So many other factors are involved in data management. Right? Also, these drones can manage the pollution data. So we call it pollution-free intelligent drones. The multiple drones we can see. They're flying on the sky and making certain patterns. Initially, drones are like this. All 100 drones are lying on the ground. And after the programming, it will go on the sky, make this kind of patterns. What patterns you make? If you want to make IEM on the sky, it will be IEM. If you want to make a guitar, it will take the guitar position. You can change the coordinate. Very simple. Using your mobile phone, you can do it. What you draw in your mobile phone, that will be done in the sky. Right. If you want to write auto FDP, it will be auto FDP on the sky. Initially condition is this. After programming, this will go for 15 minutes on the sky and show the light show like this. Either guitar or birds or auto FDP, whatever. You can write India also on the sky. The pollution-free lighting systems, right? Very popular nowadays. So another thing is called in drone data science, something is called privacy. Privacy is very important. Privacy means, what is privacy? Do we need privacy, madam?
So definitely the third party who is not authorized for this program can't or shouldn't be entered to this system,
Exactly.
program. That's the
So you
privacy.
allowed only the authorized people to come, right, to this
Yes,
WLS.
yes.
So there's something called federated learning or distributed learning, which provides privacy, scalability, and performance. What is that? You can see that this picture, this one drone is on the sky. You can say W1, W2, W3. This data is going from the patterns from these mobile phones, cars, and everything towards the central zone, right? Where the identity of the person is not, or device is not disclosed. See, say user one data, user two, W2, user three, W3. All is gathered in the top level, and top level aggregates, and then they send the data to the zone itself. That's called W. Can you see the blue lines? W1 is every user. The thousands of users, their data is going to the sky, means on the central zone. The local pattern is going W1, W2, W3 on the top, right? Aggregation is happening on the top. Then it generates the common model called W. That W model is distributed to everyone. It is very much similar to your WhatsApp. Everyone uses WhatsApp? Yes,
I think everyone.
Everyone, right? Madam, what is your name?
Sir, I mean Kajori Shur.
So when you're writing Kajuri to anyone, means to your WhatsApp, If you type K, what is coming in your mobile phone?
If I write it in WhatsApp, then definitely
WhatsApp to someone. If you type someone K for Kajuri will come, right?
Yes, sir. Kajuri will
But
come.
when I write, okay, let me see when I'm writing K, whether Kajuri is coming or not. When I'm writing K, my mother's name Krishna is coming, not Kajuri. Why? Tell me why.
I think, sir, it is because for your phone, the mostly used name against K is that one. That's why maybe.
Yeah.
Oh.
Yeah, Krishna is coming because I write my mother's name Krishna, so it is coming here, not Kajuri. Because your mobile phone is trained like this, right?
Yes, sir.
This is called local learning, local pattern, and that is
Definitely.
nothing but W1. Clear?
Right, right.
So this is for Devashish phone, it is W1. For Kajuri's phone, it is W2. For Shobendu, it is W3. For Motoshi, it is W4. For Amartya, it is W5. Clear? All the data is going to the top. After that, we update the WhatsApp, right? After 1 month or after some day, we have update from the Google Play Store, isn't it?
Yes, sir.
That is nothing but W. That's common with common. Everyone has same W. The global pattern is updated on the device itself, and the same W is going to each and every mobile phone user. Here.
Yes, sir.
So identity, everyone contributed. Kajuri is contributed, Devashi is contributed, Motoshi is contributed, Shomendu. Shomendu is, but identity is not disclosed because only pattern is gone. But
Right.
all the W is given to all the users, right? So this is known as fairy tale learning, where the identity is not disclosed. So just see this picture. Say suppose Calcutta has 10 to the 7 people, right? We have selected randomly, not randomly, those who have very good phone. Madam, Kajuri madam, you have iPhone?
Yes, I have.
Very good, excellent. So if you have iPhone, your quality of the phone will be good, right? Compared to my phone. Means I have only Samsung 35, right?
Yes, though
Yes,
my
quality.
phone is old, but
No,
it's
still it is, not below 50,000, right?
yes,
My phone is
sir.
also not small, it is 30,000 phone, right?
Right.
So your phone you have invested a lot. So suppose Kajuri madam and I am in Salt Lake. Actually, I am in Salt Lake now. So
20 minutes.
so if randomly we select the people from Calcutta out of 10 to the 7, 100 will be only iPhone user or Samsung S series. Those are very good phone because this phone can capture very good quality picture, right? Picture resolution will be good, quality of
Right.
data will be good, right?
Right,
Because you have
sir.
more quality sensors in your mobile phone. Apple has more quality sensors, right?
Right, sir. Right.
You understand now why others will not be selected? You will be selected here because your phone is costly phone and your phone not for cost. Actually, the phone data is very useful, right?
Yes, quality
So
is better. That's why.
quality. See, I am only talking about quality. Quality is the last word. So out of say, I've not drawn 100. Say, suppose I've drawn only 3 pictures, right? 3 phones. Suppose there are 100 phones like this. They have gone through this learning technique in the machine
Yeah.
learning techniques.
Yes.
And out of that, 10 model is generated. Machine learning generates the model, right? Training, testing,
Yes.
engineer generates. Out of the 10 model generated by the engineers, the best model is downloaded to every user. Every means all the 10 to the 7 users. Yeah.
Yes, sir.
This is known as distributed learning or federated learning. Clear?
Okay. Okay.
Now see, this 10 to the 7, out of that only 100 selected. But when it is downloaded to everyone, does anyone know? Does this first one know who has contributed? Answer is no. Because everyone update the WhatsApp, right? Here.
Yes, sir. from where it is trained, that is not known to the other party.
Exactly. Only it is trained by the iPhone people like Kajuri madam and others, right?
Right.
Because you have
Right.
good quality of phone. Maybe if someone has i17, maybe then you will not be selected. Clear?
Right. Right, sir.
Right? So these people do not know who has contributed. Maybe you will be rewarded with 10 GB data free kind of thing. Nothing is free in this world.
Yes.
You will be rewarded since your
Yes.
mobile phone is
Yes.
used for training purpose, right? But
Yes.
these people do not know, this 1 crore people, 10 to the 7 people do not know who has contributed. Here.
Correct. Correct,
So
sir.
is it not privacy preserving technology? Privacy is preserved.
Yes.
Because
Yes.
identity of Kajuri is not disclosed. Identity of Showman is not disclosed. I think Motoshi madam also has iPhone, right?
Yes.
So Motoshi madam also their identity is not disclosed, right?
Yes,
So
sir.
this is known as privacy preserving learning. So what I've started saying that this one, parental learning is privacy preserving learning, isn't it? So this is the privacy. So if you see the drone, only the pattern is going. Only the patterns are going. W1, W2, W3. It is aggregated and global model is generated. And that is called WG. This WG is model going to every users. So identity of the person is not disclosed. So that is the beauty of parental learning. And this is started by Google in 2016, almost 9 years before, right? And is widely used in any app. Listen, everyone, any app they use this kind of parental learning. So popular machine learning technique, distributed learning technique. Yeah. Nowadays, also something is called quantum computing, which is very popular nowadays. You know, it's very powerful. Quantum computers are very powerful. We are using quantum drones. You know, quantum computing means, they use qubit. You heard about qubit, madam?
Yes, sir.
In case of classical, we have bit. In case of quantum, we
Yes.
have qubit.
Yes. It's a
In case of
unit
classic,
for quantum
yes,
computing.
yes, for quantum computing. In case of 7-bit to 9-bit, normal classical computer, how many bit increase? 7 to 9. 9 minus 7 equals to 2, right?
True. Hmm.
But in case of quantum, it is 2 to the power 70 to the power 9. How much
Yes,
bit
sir.
increase? So it is huge, isn't it? That's why
Yes.
quantum computing is exponentially powerful. That is the reason for huge data collection and see this kind of aggregation. Aggregation. When huge amount of data is coming, normal classical computer takes huge amount of time, right? Generally, we do not update your Google from Play Store every day, right? Do you update every day?
No, no, it's a rose joiners. No, no, not
Exactly.
every day.
Then
Hmm.
why? Because this aggregation takes time. But if you use this kind of quantum computer, it will be done in one day. Every day you can update. Your model, your system will become secure, safe, and updated. It will be good for your mobile phone. So when quantum computer will come, quantum computing will come, the system will become robust and very efficient. Here. So quantum computing is coming in big way in India also. We also have NPM, National Quantum Mission. Next month, December, we are having this Quantum Coal conference also. If anyone is interested, they can join us. So quantum computing is very, we have fairy learning, quantum fairy learning, deep learning, quantum deep learning. So everyone quantum version is available. What is the advantage? It is very fast, extremely fast. That means 3 days job can be done in 3 seconds, right? So much fast. Now we have 100 qubit means 2 to the power 100. 8 qubit means 2 to the power 8. That is the computational speed. Extremely high speed. Even for quantum key distribution, quantum security, quantum repeater, quantum supremacy. Even China achieved quantum supremacy. So powerful the country is. They can send the data to this moon using these quantum key distributions, right? This is one of the examples. Just look at the picture. I'm not going in details. Drone to drone, satellite to satellite, quantum key distribution is possible. We call it QKD, quantum key distributions. Transmitter to receiver, one drone to other drone. Using this quantum key, we can very difficult to break. Very powerful. Quantum key generators are very powerful. This is the quantum key generator, and these are two receivers. On the picture, you can see one is generator, other two are receiver. So they are very powerful generator. Very difficult to break the states because they work in the quantum entanglement, quantum superposition technologies, right? I'm not going in details. It will take a lot of time to discuss how this quantum technology works, right? See, optical links is basically optically. Quantum things operates in optically. Transmitter to receiver, right? Quantum. These are the details of circuits here. Quantum circuits. Now see, the whole country. India is a very good, a big country, right? You know, India has big borders, and we are very good friendly neighbors, right? They love us so much, and that is the reason the border is secured with the help of the drones. And to capture and process the data, we need very high powerful computers. Nowadays, it's done by the supercomputers, but now we are thinking to use quantum key distribution so that very efficiently and effectively we can deploy the drones and we can find out the intruder, anyone is crossing the border or not, right? Using this kind of drones. So instead of sending people, now our borders are automated with drones, where quantum computing may play a major role. This is on the experimental stage. These are all the experimental pictures, right? Clear? So what you can conclude here, we need to have the intelligence, we call it drone intelligence for sustainable smart cities. I have shown you that how drones are used to control the traffic lights, drone doctor, drone power management. Okay. Also, I have mentioned federated learning, distributed learning techniques, which provides privacy preserving drone computing, right? I have also discussed about the broker, MQTT broker, PubSub models. Also, we have discussed about the security of drones attacks, various attack prevention using federated learning techniques. And also, I have discussed about quantum machine learning, QML. Everyone know about ML, but we are now talking about QML. Advantage is extremely fast operation. Quantum machine learning is there, right? So we have this book. You know, if anyone is interested, they can go through this website, and if you want, I can send you the book also, no problem. I'm not asking you to buy because it's very costly, 11,000 rupees. So I'm not asking you to buy. But those who are interested, you can go through this book. We have given details how this data is managed and how the efficiently classical and quantum domain level this IoDT is working together and performing the jobs very efficiently. Okay. I think I've covered some basic sections of Internet drones and how this drone data is managed efficiently and effectively for security and privacy. Okay. Thank you very much.
Thank you, sir, for this wonderful session. So, all the participants, I request them to kindly unmute yourself and ask the any question, any doubt if you have.
Madam, is it understandable? Means what I want to
Yes,
say
sir.
that want
Yes,
to
sir.
convey.
It's very nice session. And one of our participants is Farhana Siddiqui says that is a wonderful session with very nice animations.
Okay. So if you want this book, I will also send it to you. We can send it to the participants. No
Yes,
problem.
sir. Yes, sir. Definitely, definitely, sir.
And
It
one
will
of the
be a
author is
pleasure
also from
for us.
IEM. I think you know Amar Tupred.
Yes, sir. Definitely, Amartya sir is always with us. We know him very well.
Yeah. If you want, I can share it this book to you, and you can send to the participants. No problem.
Yes, sir. Definitely, definitely. It will be very great thing for us for this FDP also and all for the participants.
Sure, sure. I'm not asking because you know it's very costly, 11,000. I'm not asking anyone to buy in India at least. But okay, but you can consult. You know, very interesting things are given there. Yes. Thank you.
Definitely, definitely.
So anyone want anytime you can mail me here. This is my email ID. So WhatsApp number is here. I'll send you. I'll try, happy to give the answer to you over the emails or in WhatsApp. Okay.
Okay, sir. Thank you, sir. Thank
Thank you.
you
Thank you,
to
everyone.
being
Thank
with
you.
us.
Sure.
It's a very late at night, I know, but thank you for your time.
Yes. Thank you. Thank you, everyone, for staying so long. Almost 250 participants. Thank you.
Yes, sir.
Hello, sir.
Thank you, sir.
Evening, sir.
Yes. Thank you. Hello. Yes, you can carry on.
Sir, regarding this QML or quantum machine learning experiments, sir, is there any interface where we can submit our code and it can run on the real quantum machine?
Yeah,
And
see, I have a project from IBM Q. So, IBM Q we can run. They give 10 minutes free for access. And also I have a project from Amazon AWS, which also gives access.
okay. So for that, something like
Limited period free, but if you do big experiments, you have to pay. Nothing is free, actually.
okay.
But
Thank
some
you.
simulators are there, but not so reliable.
Yeah.
But if you want to real computers, then you have to collaborate and get the access. In India, slowly these things are coming up. Okay.
Sir, any kind of no for IBM and all, there is a earlier it was some notepad kind of things were there.
Yeah.
So when I searched, it was showing it is discontinued like that.
No,
So
it is there for a few minutes. So I can, you have my number, right? So you can send me, I'll give you the links. Okay.
sure, sir. Okay, thank you, sir. Thank you.
Any support anytime, we are for
Okay.
you only. Okay.
Thank you, sir. Thank you.
Okay. Thank you very much, everyone.
Thank you. Thank you, sir.
Thank you. Bye. Good night.
Bye. Good night, sir. And for the participants, tomorrow is our last day of this ATAL FDP. So, and the session will start at 2. So I will request all to join the session at 1:45 p.m. Thank you and good night.
Okay, ma'am. Thank you.
Thank you, ma'am.
Thank you.